Hello, this is Al Edlund. This is going to be a brief presentation on some of the data definitions that might be applied to documenting a data center in preparation to move. So let's get into it. Describing the data center it is much like the ancient story about the six blind men and the elephant, where we have multiple people trying to get a view of an entity, and each of them describing this entity within the construct of their own image. The definition we get into is trying to combine these views into a manageable set of information that can be shared among the groups. As the foil says, you get extra credit in this case if you can put your blind men into a herd of elephants, or worse yet, a zoo, to see if they can all describe the same things the same way. The challenge is to move from that physical site implementation of the racks and the components in the racks to a data model that can be used to automate that documentation based upon the data. In addition to that, we have the other aspects of things like applications, operating systems, and the whole myriad of cabling and infrastructure. We're going to base our design on four general areas. That of components. We're going to take a bill of material approach with both attributes and hierarchy. We will need some tables for standalone support, client and asset information. We will need location information, geography, cabinet rows, and things like that. For locations, the primary tables we're going to use is one that describes our client, the physical locations that we're involved with, and this goes beyond that of the requirement for the data center in the fact that we may want to describe locations of our business partners, other entities within our enterprise, and things like that. We have another table associated with it that has attributes of locations, and we put this in there specifically because of a requirement where we may be documenting a campus, we may be documenting a large building in an urban location. Cabinet rows is put in there as a documentation function to ease the process of drawing it. Each of these, of course, when we get into our attribute locations, is how we attach our components and describe what is physically there. We've added an additional table, which is a SQL Server construct for geographic data. We'll have a table for product data. Product data is going to be used to describe the vendors that we have in our components. It will be used to describe the Visio stencils and the master shapes associated with this product. We have some additional fields for recording of error data for when we validate it, and if there's a requirement, we put in some short characteristics for environmentals. Component attributes is a drill down, and these become mini bill of materials of themselves. Cabinets is one attribute of a component. Rack can be a component. It is associated with those cabinet rows we mentioned previously, and you can see how we escalate up to the product data and location information. Network information within this set of definitions is actually the connectivity we require. Domain name, IP addressing, subnet masking, WWN IDs, and this data is typically associated with a port on a component. For ease of use in some of our drawing, we've also associated it with the components. Port data is where we attach communications links, and communications links will have two port keys, one of course for each side of the link. We've included storage in our definitions because of its importance within a server world, components being servers and workstations. We've also included as a sync virtual host because they also have storage requirements. We've broken it down: physical storage and logical storage. These play back to WMI definitions for specifically a physical disk and a partition. External storage has the additional issue associated with it that there will be a network component, which ultimately points back to port data, and possibly components other than the one that we're describing the data requirement for. It's not unusual when you walk into a data center to see labels on servers that, in theory, name the server, when in fact often what they're describing is the system load that's on it. Operating systems come in multiple versions. These are typically what we would call platform dependent. We would expect to see Intel teams, Unix teams, etc. monitoring this and the applications associated with it. A virtual host, it has a special case in that, first of all, it is a child of an operating system, and in addition it will have an operating system loaded upon it. We don't differentiate between application services such as websites and email systems, because inevitably what you end up with is other applications that will loop back into it. We've put fields in here to identify peered applications. In summary, we end up with product data, we end up with asset data, we end up with location information and drill down. It becomes pretty clear fairly quickly that trying to manage all of this with spreadsheets will be exceptionally difficult. The next thing we want to do is, once we start looking at our stakeholders, the teams, how do these map out to the tables, and are they in fact covered? Things like facilities that have a requirement to know components, understand locations and the product types of information that's out there, the rack and stack types of things, the network teams that have their requirements, our platform teams, the Unixes, the Wintels, and security, storage and platform teams, applications, and finally, when we get into how Visio might be applied to approaching this thing, it's not unusual to hear requests for functionality that includes Visio for visualization, which is its primary role, the ability to attach data to shapes within Visio was significantly enhanced with Visio 2007 Professional Edition and is also in a Visio 2010. Unfortunately, adding or deleting records in your data source or in the shape does not guarantee that it will be mirrored into the other side. So the next request we often hear is Visio for data entry. This is the round tripping of information. The ability to take data into the drawing, the ability to edit the data within a drawing and put it back to the data source. One of the unsaid focuses in this point, though, is that it removes Visio drawings as the data source. The data repository is now in an external location. The next thing we often hear is Visio using the drawing as a direct port to interact with the device, and finally the automation of the creation of the drawings. The unsaid thing here is the Visio drawing becomes transient, because as we need a new one or an updated one, we will create it and thus not require the other ones. Some examples and references for Visio drawings. Stage 1, link to data. There's a number of things here. David Parker's book is excellent. Round tripping of information. The Visio 2007 and 2010 software development kit have examples of that. We have put examples of how to interact with devices on Chris Roth's site. Chris is a Microsoft MVP for Visio. And finally, drawing via automation. There's some simple examples in the SDK, and David Parker has done many things as well. We've placed a number of presentations up on YouTube, like this one, that can give you examples and thoughts on how you might approach this. And that's all for this one.